All right, so law of sines is given to you here. Sine of A over A equals sine of B over B equals sine of C over C. So you can set two of those ratios equal to each other to create a proportion. You just need, like I said, three different things, either two angles and a side or two sides and an angle to be able to use that. Don't need a right triangle, though, which is nice. It still won't work. So the proof, here it is. So you'll see here my pink. Is that pink?
It's like a lavender.
So if you look at that triangle, the lilac triangle, it is not a right triangle. Okay, but what we're going to do is drop this altitude, this dashed line, call it y, and create actually two right triangles next to each other. So we're going to use right triangle trig to prove the law of sines. It's pretty simple one to do. So right here, we have this relationship that sine of C, here's angle C right here, is equal to opposite, which is y, over hypotenuse A. If I multiply through by A here, so multiply through by A, I get the expression y equals A sine of C. Sine of A, here's A over here, is equal to opposite y over hypotenuse C. So I'm using these two adjacent right triangles. They share the altitude I dropped in the lilac triangle earlier. And I'm creating two statements that are equal to the same thing. You see that? Here we have y equals C sine of A, but also in this right triangle, y equals A sine of C. Now, they're both equal to y, therefore they are equal to each other. So by substitution, or transitive property, A sine of C equals C sine of A. I do a little bit of moving around terms here, and voila. I have sine of C over C equals sine of A over A. And by changing the letters in that picture, you could get the third piece, sine of B over B, can equal either one as well. So that's the proof of it. Pretty simple proof, based on right triangles, which we expected. That's a big thumbs up. That's an elegant proof, very easy. But it's all just based on dropping this altitude, y, that creates two right triangles, setting up a sine statement from C and a sine statement from A that both share y, and then setting them equal to each other. So have your calculators ready. Calculators need to be in degree mode. Let's keep them in degree mode for this unit. We're going to become more familiar with degrees. Degree familiarity with stuff with degrees. Calculators are unsheathed, hopefully. Ready to go. All right. So here we go. We're given this just two angles and a side. And the instructions are to find the length of side B. So if I draw a triangle here, let's see if we can draw a triangle. We have a 40, a 45, 40, 45, that adds up to 85. That means the third side will be what? 95. So it's an obtuse triangle, just barely obtuse. So it's something like this. And so it's just slightly bigger than 90 degrees. Perhaps this down here is the 40. And this up here could be the 45. And so we're going to call the 40 B. So opposite the 40, we'll call it lowercase b. Here's there isn't a right angle there. I almost drew a right angle. Then we have A here And, oh, okay, actually we're going to need this 95. So the 95, we'll label that 95. That is actually angle C, and then we have C is 4 over here. So I am looking for B. Did I ask you to find A as well? Oh, okay. When it says solve the triangle, then what am I asking you to do? Find everything, all 6 parts. So I have the 3 angles. That's done. I have one of the sides. What ratio could I set up to find, for example, side B? Sine of 40, that's right, sine of 40 over B equals, now I got to make sure that the other half of my proportion, this other ratio that makes up the other half of my proportion, involves known angles and side lengths. So we have to use sine of C. So sine of 95 over 4. And what we do to solve this is we go ahead and cross multiply. You could also use the cross product property. Somehow I need to get B up at the top. You can actually just swap these two, get B up in the top, and then multiply by 4, and you've got it. You probably do all that in your head. But what this looks like is B sine 95 equals 4 sine 40. And so finally B equals 4 sine of 40 over sine 95. So with your calculators, could you find out what that equals for me? Tell me what B is. Point 2.58. So we'll just round to the nearest 10 is what we'll do for the most part. Unless I say otherwise, round to the nearest 10. So 2.6. So B is about 2.6. It's good to look and see that that makes sense. My longest side, I won't call it the hypotenuse because it's not, but my longest side is 4. It's opposite the 95-degree angle. That's how I know it's the longest side. So 2.6 is B. What do I expect for A in comparison to that 2.6 for B?
A little shorter.
A will be a little bit longer because it's opposite a slightly bigger angle. Okay, so can you give me the setup for it? What I like to do, let me just show you what I do with these. Circle that. We're going to reuse that, okay? The known one we're going to reuse. We could do sine of 40 over 2.6, but what if I had messed up on finding the B? We don't want to then take that mistake and carry it on to the next calculation. So we're going to take that sine of 95 over 4 and set it equal to sine of 45 over A. And then I'd like you to solve that for A. So solve this one up here for A. And we know what to expect. Something slightly bigger than 2.6. What does A equal? 2.8. That's what I was going to guess. 2.8. Good. Okay, so that's a basic problem just using the law of sines. So let's get into some word problems. All right, it says, some of you might have been copying that down still. 2 people 400 feet apart measure the angle of elevation to the top of a tree at 51 degrees and 65 degrees. How tall is the tree? So nothing's a scale here in my pictures, but I move them apart a little bit. So let's make our triangle here. I'll try and do it on here. So we've got this one going up to the top of the tree. This one going down to his boots. I'm going to connect these two here. Just to be clear, it says two people are 400 feet apart, so this distance down here is the 400 feet from boots to boots. And the angle of elevation of one is the 51 degrees, and the other one is 65. So this one is supposed to be a little bit closer to the tree than the one on the left. So hopefully it looks about right. And I'm not going to draw an altitude yet. I'm going to drop one yet. So, actually, maybe I will. Let me do this. Let me just put a dash line in here, just to get us thinking about this. Ultimately, I want to find out how high the tree is. What's the problem with going directly to finding that height with the information given? Don't have enough information. What would I need to know to go directly to using sine? One side or a side, yep. So a side here, 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 or here. If I knew how the 400 feet was broken up, I could do it, but I don't. So I need to find one side. So I can find one side using the law of sine. Let's pick a side. It doesn't really matter which one. Okay, left. So let's call this x over here. We're going to call that h. So let's see if we can find x. Then we'll have our one side for the right triangle on the left. Yeah.
We just go straight to finding h.
We can't. That was the issue. Is to find h, I would need to know this side, or I would need to know how this 400 feet is broken up. Otherwise, I can't go straight to finding h, because the 400 feet is not part of a right triangle. Okay. So using a law of sines, I could say sine of 65 over x equals, here's the other problem. I can't use sine of 51 because I don't know this opposite side. If I had known this opposite side, I would have gone directly to finding the height. But can I find this angle over here? Yes, I can. How do I find that? They all have to add up to 180 here. These have to add up to 180. So what is this angle then if these must add up to 180? 64? 64 degrees is what that is. Okay, now I can set up my law of sine. Sine of 64 is opposite the 400. Now I have my 3 bits of information, and I'm left with finding x. So cross multiply and solve for x, and you should get about 403.3 feet. So that is my x over here. I'll label it. It's about equal to 403.3. Now I have the hypotenuse of this little right triangle here. Okay, I now have the hypotenuse of that highlighted right triangle on the left. So I can go ahead and find the h. So I have the hypotenuse, the h is the opposite. Which one of sine, cosine, or tangent involved O opposite and h hypotenuse? So sine. So we have sine, yes. Sine of 51 equals opposite h over hypotenuse 403.3. And then you'll cross multiply and solve for h. So h is about equal to 313.5. Kind of depends on how far you carry it out. If you carry out your decimal here till the end or not. But close enough. 313.5 feet is the height of the tree. So another way to indirectly measure the height of something is law of sines first, and then use the right triangle next. So any questions on that one? All right, number 3, looks like I have some interactive stuff here. I don't have the problem written up there though. I had to leave room for my picture and the little interactive things that come in here. So it says to measure the height of a mountain, a surveyor takes 2 sightings of the peak at a distance 900 meters apart. So 2 sightings, here and here, 900 meters apart, on a direct line to the mountain. The angles of elevation are shown. So the angles of elevation are 35 degrees and 47 degrees, respectively. If the surveyor's equipment, or eye level, is 2 meters tall, what is the height of the mountain? So there you got this 2 meters tall. So we're going to have to remember in the end to add 2 meters to whatever we get as the height here. So my goal is to find h, the height of the mountain. And so we have this triangle right here in orange that is not a right triangle, right? It's not a right triangle. We need to use that triangle first to find, go ahead and find the information that we need in order to get the height here. If I can find, for example, this length right here, this dashed line right here, that would then be the hypotenuse of this right triangle on the right. So let's see, is there a way I could figure out the length of this dashed line right here?
What dashed line?
This dashed line right here. If I can get that one. Well, that one is opposite the 35, right? And then here I have a 900. If I could figure out the angle right here.
12, just do that. It's 12.
It's 12. Okay, how do you know it's 12?
Because I did 180 minus 47.
Okay, 180 minus 47 will give you this one, which is 133. And you add 133 to 35, you get 188, leaving this to be 12 degrees. Okay, good. So we have sine of 12 over 900 equals sine of 35 over, let's call this x. And x is going to become the hypotenuse of the right triangle. So 2-stage process. Use a lot of signs to find the length that we're going to need when we go and use our right triangle trig. So cross multiply, divide, and you should get x is approximately equal to what value?
2,482.
Yeah, that's right. 2,482.9 feet. So if this is 2,482.9, I can now use some right triangle trig to find the height. So I have this 47-degree angle here. I have the hypotenuse. I need to find the opposite. Opposite and hypotenuse is once again sine. So sine 47 degrees equals height over 2482.9. So opposite over hypotenuse. So the height of the mountain, opposite over hypotenuse. So it's correct. Sine of 47 is the opposite side h. Hypotenuse. Now, well, an h doesn't represent the entire height of the mountain. I've got to add 2 meters to it. So I'm just finding h. We'll just call it h for now. So h ends up equaling 1,815.9. So the total height of mountain is equal to 1,815.9 plus 2, which equals 1,817.9 meters.
Wait.
Yeah, these should be meters all the way through, so this should not have been feet. These are meters all the way through. So just to remind, I mean, two-stage process, again, kind of like the previous problem. Just remember to add that 2 meters to it for the height of the tool that you're using to get your degree measured. All right. So you have several problems like this, where you use law of sines and then tangent, cosine, or sine. In geometry, we discussed this kind of off the cuff or kind of tongue-in-cheek about, ASS is not something that is, if it swears at you, it's not going to prove that triangles are congruent. There's a reason for that. It's okay, hold on here. There it is. I have a little geometer sketchpad diagram that will show you why that is. If you're given two sides and an angle that's not included between the two sides, it does not necessarily determine what the triangle will look like. You can actually, there's a little hinge effect that happens that would allow you to get two non-congruent triangles. Let me show you what that looks like. All right, so here's what the law of sine says, just repeating the law of sines. Let's go to the ambiguous case. Here it is right here. Where's the ambiguity? So we have an example of an angle given right here, angle A, and then a side that's fixed at side length B, and another side fixed at side length A. And what you can see here, that's a fixed one. Do you see how A, the length of A is not changed, yet I have two different triangles? I don't know if you see them here, but here's one of the triangles. It goes from angle A up the side, down here, and over here. Notice that the green, the red, and angle A did not change. Okay? But I could also, this is what I mean by the hinge effect, I could swing this out, that's what the circle's about here, swing that out and create another triangle right here that also has side-side angle equivalent to side-side angle in the other triangle, and yet the triangles are not the same size. They're clearly not congruent. So if we can see that on that sketch. But that's the purpose of that sketch. And you can change these around. You can change these around a little bit. Eventually you get to a spot where it is fixed, but there's a whole range in here where there's some what we call ambiguity. In other words, we don't know if this green piece hinges in towards angle A or hinges out away from angle A. We can get two completely different triangles in each of those cases. So, going back to the notes here, we have some options. We could have 0 triangles with the given bit of information. It's possible, this goes back to geometry, it's possible that I could hand you 2 lengths and an angle that won't constitute a triangle. Let me go back here and see if we can demo that on the geometry sketchpad here. So we could have, oh, there it is. So if I shrink up the green enough, look at this, it just doesn't even touch. I need to get rid of that little. So that would be, you're given a side, you're given another side, you're given a fixed angle, you have no triangle. Okay, so it's possible to have no triangle with that bit of information. You could also end up with 2 triangles, and then you could also have only 1 triangle. So those are the 3 cases. First thing you want to do is get an angle. So you're going to go through the process of using the law of sine. See, if you're given side, side, and angle, right? That's 3 bits out of 4 bits of information. So you can get an angle. Now, whether or not that angle will constitute 0, 1, or 2 triangles, we'll see. But you're going to get an angle. You'll know right away, actually, if there's no triangle determined. You'll get an error message, okay? And then what you're going to do is test 180 degrees minus that angle. If you get yet another angle, a different angle, then that constitutes 2 triangles. Otherwise, you have just one triangle. I'll show you what I mean here. These three examples, we're going to see one of each of these ambiguous cases, 0, 1, or 2 triangles. And all you need to do to get an angle, just go through the process of using the law of sines to find that other angle. Okay, just go for it. Or set it up, see what happens. And then we're going to test 180 minus the angle. And at that point, we'll know if we have just one triangle or if we have, in fact, two. They're determined by that information. Okay, so if I think about what my drawing might look like on these a little bit. So on this one, maybe draw a triangle something like this. So we have the 95 here. So that's 95, that's going to be B. And so the 14 will be opposite the 95. If you don't draw the triangle to scale, that's fine. I'm just trying to think about what the triangles would look like as I went through these. But you really can't tell until after you found the angle and then find which case it is, and then you can draw it. And then A is 9, so I called this A up here, so this was 9, and then this was C over here. And then this will be little c. So it says solve the triangles. In other words, find capital A, B, and C, and lowercase a, B, and C. So here we go. Can you set up a law of sines problem to find, let's see, which one could we find? To find angle A. Okay. So we have sine 95 over 14 equals sine A over 9, right? So sine of 95 over 14 equals sine of A over 9. So we're just going to find the angle. That was our first step up there in the instructions. Get the angle, okay? Just get the angle and we'll go from there. So once again, you might not know exactly what this picture looks like until you go through this process. I don't know for sure that 9 is longer than C as it looks in my picture. I don't know that yet, but we'll find out. So I'm going to cross multiply. So I have 9 sine of 95, actually just multiply by 9, all over 14 equals sine of A. And then with your calculator, you're going to use inverse trig to solve this. I'm going to solve this once, and then we'll skip this step in the future. But it's A equals inverse sine of all that mess, 9 sine 95 over 14. Okay, once you get to this point, you should understand that to solve for the angle A, you have to take the inverse sine of all that stuff on the left, that expression on the left. So in your calculator, in degree mode, go ahead and find what inverse sine of 9 sine 95 over 14 is. Go ahead and do that. You should try it. Make sure you're typing it in correctly before you attempt the homework here. Tell me what you get for angle A to the nearest 10. 39.8 degrees. Okay. Anybody need help with that? If you need help with that, I can give you a minute to help figure out. 39.8 is what you should get. Take another 30 seconds to give everybody a chance to try that. I really want you to do it on the calculator because I don't want you to go home and be doing it incorrectly in terms of typing. So that's what it should look like. The way I wrote it up there is exactly how you type it into the calculator if you want to do it all at once. So 39.8. So let's get the angle. 39.8. Okay. Then I had said to do what? 180 minus just one of these, just this one. So 180 minus 39.8 gives me 140.2. And then take a step back here. Let me write in 39.8 here. If that's 39.8 and this is 95, could I have an angle of 140.2? Actually, go back here. With an angle of 95, could I possibly have an angle of 140.2? Why not? Not possible. And we might want to write this down. Why? Not possible. Because 95 plus 140.2, what does that equal so far? Yeah, okay, we'll just do that. is bigger than 180, then we don't even need to know what it is. But would you agree it's over 180? So for that reason, which of the three cases is this? 0, 1, or 2 triangle? This is the one. This is the one. This is the one. So angle C has to be whatever, 95 plus 39.8. Subtract that from 180. I got 45.2 is what I got. Yeah. 45.2 degrees. And so you can just draw your one triangle and then label it, and that would be good enough. We got for C to solve the triangle. So we still need to find C. So how am I going to find C? Now I know this angle. Right? Let's set it up again. Maybe go with the one that we started with here. And do it again. So sine 95 over 14 equals sine 45.2 over C. Cross multiply, solve for C. And I got C equals to the nearest tenth, 10.0. So now I've solved that right triangle. Okay, so just get an angle and then test 180 minus the angle and then see if that angle would work in the triangle given to you, okay? Let's do that again on this one. So I know this is going to be sine 65 over 6 equals sine of B over 7. Notice I'm not even drawing the triangle. I'm not drawing the triangle yet. I don't really know what it looks like or if it even exists. I'm going to wait to draw it. I'm not drawing it yet. But I know that if this is A and this is A, they've got to be connected, and then sine of B has to go with 7. Cross multiply, you got 7 sine 65 over 6 equals sine of B. Go ahead and find inverse sine of 7 sine 65 over 6, and what happens there? What has to happen? They're giving you an error message? Why is that?
Because there's no triangle.
That's right. This triangle does not exist. You can't have a triangle with these two lengths and that angle. It won't work. But also, another way to think about this is this number right here is, if you just calculate 7 sine 65 over 6, you will get a number that's bigger than 1. Yeah. So this is undefined on the unit circle. So no triangle. So that is our 0 triangles case. And then you could probably guess what my third one is here. No, 2, yeah. So this will be the 2 triangle case, okay? I'm going to hold off to draw the triangle. You actually don't even need to draw it. But can you tell me what my setup is here? Good. Okay. So sine of B over 12. So B, you should be able to solve for B then now. Hopefully you've got that wired. And when we solve for B, we should get the angle 66.6 degrees. Hopefully you're getting that. So I've got angle A, I've got angle B, I've got side A, I've got side B. Before I go and find side C and angle C, let's test this and see if it works. So the test is take 180 minus 66.6. Okay, 180 minus 66.6 degrees. And what do we get? 113.4. Now, if you take 113.4 and add 35 to it, it's definitely less than 180, right? So 2 triangles exist in this case. This is the ambiguous case with 2 triangles. So let's run through and get all 3 angles and all 3 sides here and see if we can maybe draw a picture. So if I were to draw a picture on this one, it might look maybe something like this. Here's a 113. I'm gonna make that bigger. It's got to be obtuse. Let's make it a little more obtuse than that. Okay, so we have 113.1 degrees, and then we've got a 35-degree angle. And then if I take 35 plus 113.4, this should be a 0.4, I think. Then my other one is 31.1 degrees. So they have to add up to 180. So 113.4, 31.1, 35. The side opposite the 35 was 7.5. And then the side opposite the 113.4 should have been 12. So I have one more piece to find, the side opposite the 31.1. We're going to do something with that in just a minute. Sorry, I'm drawing the other one first. Sorry about that. We have another triangle that has a 66.6 in it instead of a 113.4. Let me draw that one now as well. So that one might look kind of like this. It's an acute triangle. And so here's my 66.6 degrees here. And then opposite the 66.6 would be 12. And then let's see, what else do we know? We know 35. And then opposite that is 7.5. And then if we have a 66.6 and a 35, then this up here has to be, I agree, 78.4. And then to find the side length opposite the 78.4. So let's see here. All right, so I've got 2 things to find. Right here I need to find the side opposite the 31.1. And over here I have to find the side opposite the 78.4. We've got a couple other calculations to do. So we've got sine 35 over 7.5 equals sine 31.1 over, I think I'm going to call that C. This is C right here. 31 point, yes, it should be 31.6. Right here, you mean? So right here, change that to 31.6. You guys got that? You're right. This should be a 31.6 right here, since this is a 113.4. 44, 45, yep. So C should be approximately equal to about 6.9. So this triangle is done. We have all 3 sides and all 3 angles. Did I get it kind of to scale? I did. Biggest angle, biggest side, middle angle, middle side, small angle, small side. You really can't do that though until you've got all your pieces, and then you can draw the triangle. And then here I can set up again sine 35 over 7.5 equals sine 78.4 over C. So this is a different C in a different triangle. And then here, C should be about, going through the same process. I got 12.8. And that's my longest side for that acute triangle. So this is the case where we have two triangles. That's it. So the ambiguous case. Steps are to just use the law of sines to get the angle first. Are you with me? So get the angle. You don't even have to draw the picture. Just use law of sines, get the angle. As long as it's labeled according to the way we set it up. Big A is opposite little a. So get the angle, do 180 minus the angle. If what's left over will work with the angle given, in other words, not be over 180, then you have two triangles. If it won't work, you have no triangle. Or, well, you'll know you have no triangle because when you do law of sines originally, it'll give you an error. And then if 180 minus that angle won't work, then you have one triangle with that particular angle. All right. So I have some practice problems for you to try. You grab a computer.